Okay, so today we'll solve GET 2022 question from functional analysis. This is the question number 38. It's saying that let C00, it's denoted a one norm space. It's saying that all this is infinite string such that xi is a real number and I varies, this index varies it over natural number such that xi is non-zero for only finitely many indices. Means this space is contains a infinite string one sided so that after finitely many all entries are 0. So it has means finitely supported. Now it is saying that let x1, x2, x3 is in this space and define the norm for any point. It's taking the supremum because there are only finitely many points. So supremum we have, they are bound finite. So supremum by supremum of mod xi each coordinate. Now define two operator from C naught naught to C naught naught. What is saying? F it's taking point x1, x2 dot 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 xn dot dot dot. It is mapped to 1 plus 1 into x1, comma 2 plus half into x2 dot dot n plus 1 by n into xn dot dot. And g is defined like this: x1 by 1 plus 1, x2 by 2 plus half, like that, and xn by nth coordinate is xn by n plus 1 by n. So two operators are defined. Now it's saying that four options are given. You have to check means f or g are continuous or not, right? So this is the question. So for this is the NPTEL reference. Okay, so let's try to solve this one. So what it is given, C naught naught a space given. It is saying that all such x1, x2 like that, xn dot dot such that xi not equals to 0 or only finitely many. Indices I. And where I belongs to natural number, right? So this is the space. Now define this two operator f from again the norm. What is the norm? Suppose x is this x1, x2 dot xn. Then what is norm of x? It is the supremum over all xi such that I is a natural number. Then define two functions f from C naught naught with this norm. This is denoted by norm infinity to C naught naught via f of x1, x2 dot dot xn dot dot. So where it will map? It will map to 1 plus 1 into x1, 2 plus half into x2 dot dot n plus 1 by n into xn dot dot. And how g is defined? C naught naught with infinity norm to C naught naught g of x1, x2 xn dot dot. It is x1 by 1 plus 1, comma x2 by 2 plus half dot dot xn by n plus 1 by n, right? So first check that f or g continuous or not. So what is, they are linear operator. Here continuous means they are bounded or not, right? So we'll show, so first we will show, so we have to check that we will show that f is not continuous, means we'll show that basically this is the meaning that it is continuous. Norm of x infinity, this will not hold. For all x in c naught naught, this will not hold. Means this is the saying that f is continuous, f is not continuous. This inequality will not, means there does not exist any c such, or means there does not exist c such that this will hold. Okay, so suppose this will hold, right? So let's prove it by contradiction. Suppose it is true, means there exists c positive such that norm of fx infinity is less than c times norm of x infinity for all x in c naught naught. Then what will happen? So let's take some particular point. Choose this sequence. Choose or some y n to be the en, means this can 0 0 0 0 0 1 0 0 0 0 this at the point nth place, right? So note that these are only non-zero at one places, so they are, so note they are in C00, right? Because they are only non-zero at one places. Now what is this norm at 1, norm at n? So this has only one non-zero component, so this has, so supremum of all other 0, it only 1, so norm is 1. Now if you put this, check norm f of yn, so what is f of, so basically en, definition of f is this, so whenever in the xn plus it's 1, so it will be n plus 1 by n plus 1 by n. Now we have assumed that suppose there exists c such that this will hold. Now put it here, and this is true for all x. So therefore norm of f yn should be less than c times norm of yn, or so this side it is n plus 1 by n less than c times this has norm 1, right? Or it is saying that n plus 1 by n is less than c. C is some fixed number, and this is true for all n, right? All en, this is true for all n. So now you can take n to be large, means now take n tends to infinity. Then this will not hold, right? Left hand side become infinity, and this cannot be bounded by constant. So this, we get a contradiction. So our assumption, what we have assumed, suppose there exists c, some this will hold. So this will not hold, means, so therefore, so our assumption is wrong. Means there does not exist c positive such that norm of fx is less than c times norm x. for all x in C naught node, right? Means f is not continuous. Okay, so this one is done. So f is not continuous. Now I have to check g for g. So g, what we will show that g is continuous. Now we will show that g is continuous. Means there exists C positive such that norm of gx is less than C times norm of x for all x in C naught node, right? So you have to show this inequality, then we are done. So let's check. Okay, so what is norm? First note what is norm x infinity? So this is supremum of xi such that I is in natural number, right? So therefore what it is saying? So each xi are less than this norm, right? This norm for all I. So this is true because norm x infinity is the supremum over all xi. So each xi are less than the norm x infinity, right? Now let's take this one. Denote yi to be xi by I plus 1 by I. Means the what I have taken the what this will map, because this I have taken this to be the yi, xi by 1 plus 1. So this is y1, this is y2. Means what is this? G of x1 x2, this I am taking to be this y1 y2 dot like this I have taken the y. So note, and I is what? I are bigger than equals to 1, right? So what is mod of yi? So this will be mod xi by I plus 1 by I. So means this is xi by I plus 1 by I. And note that as these are bigger than 1, so this is always less than xi, right? And we know mod of xi is less than norm x infinity, so this is also less than norm x infinity, and this is true for all I, right? So this inequality. So what we have got? So norm yi is less than norm x infinity for all I. Now if you take the supremum, so supremum over mod yi such that I in natural number, so this should be also less than this. And what is this quantity? So this is supremum over, what is this? So this is what we have chosen this yi. Why I have chosen that xi by I plus 1 by I. Xi by I plus 1 by I. So these are less than norm x infinity. And what is this quantity? This is the g of note that what is this side? what is norm in look? What is norm Gx? So it will be the y1 up to yn dot 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 this one, right? So supremum over mod yi such that I is in natural number, and this xi by I plus 1 by I. So look that both sides are equal, right? So this side and these both are equal, so this is the norm Gx infinity. So norm Gx infinity is less than norm x infinity for all x, right? This is true for all x in C naught naught. So we have shown this one. So what is the constant here? Here constant is the 1, C equals to 1. So we have shown this inequality with the constant C equals to 1. So which means that G is continuous. Right. So then which option is got? So we have got F is not continuous and G is continuous. So the first option F is continuous but G is not continuous, so it is not true. Option B, F is not continuous but G is continuous, so option B is correct. Both G is option C, both F and G are continuous, it is not true. Neither F nor G is continuous, so option D is also not true. So option B is the only correct option. Okay.